Alright, so this video is on box plots. So the first thing you're going to do when you create a box plot is put them in order from least to greatest. So this is the first set of data that you're given. You need to order it least to greatest. Okay, so the smallest number would be 2, so I'm going to have 2 listed. You can exit out or put a check as you go through it. It makes it a little bit easier. So there is 1, 2 sets of 3, 1, 2 3s, 1, 4, 1, 5, 1, 6, 1, 8, and 1, 9. All right. Okay, so once you have them in order from least to greatest, one thing that I would have done if we were in class right now, I would have you guys put it in like a fraction strip. I would have given you guys a fraction strip. And there are 1, 2, 3, 4, 5, 6, 7, 8 pieces of data here. So since it's an even number of pieces of data, here that means we're going to have 2 numbers in the middle. When it's an odd number, then we'll only have 1 number in the middle. So I'm going to break this up into 8 pieces just so you can see. Okay, so I have 4 pieces on this side. And so now I should have a total of 8. 1, 2, 3, 4, 5, 6, 7, 8 pieces. So yeah, it's not perfect, but now I'm going to just transfer my numbers down here just so you can see this. 4, 5, 6, 8, and 9. All right, so we would have had our numbers in a fraction strip. And the easiest things to locate first are the minimum and the maximum, which are called the extremes. So those are the smallest numbers, the smallest number in the data. So this would be our lower extreme. So I'm going to label this lower extreme. And then this one is our biggest value in our data. So 9 would be our upper extreme. So our upper extreme could also be called our maximum. So I'm just going to put max there. And our lower extreme has also been known as the minimum value in the data. So those are the 2 easiest. This first number in the data, this is the last number in the data, and that's only when you list them from least to greatest. And then you're going to find the median in your data. So you can use your fingers, cross off the 9, cross off the 2, cross off the 8, the 3, the 6, the 3. So there's the 2 middle numbers. So now I know my median should be right here. And hopefully you know what number that is, but now we're going to actually calculate the median, because what if it wasn't numbers that were side by side? If it was like maybe 9 and 15, and you can't do that mentally, you might have to do the math to figure out what number exactly is right in between those 2. So in order to get that, you add the 4 plus 5, which is 9, and you take 9 and divide it by 2. So 9 divided by 2, 2 can go into 9 4 times, minus 8, 1. So now you have a decimal, and 2 can go into 10 5 times. So the median, I'm going to label it median, is 4.5. And now a median on this graph could also be called Q2, quartile 2. These graphs are broken up into different parts, so it's lots of vocabulary that you have to familiarize yourself with. So right now we've done the extremes, the lower, the upper, the median, which is quartile 2. And now we're going to need to do quartile 1 and quartile 3. So on this specific graph, there's actually 3 medians we need to find. We found the first one, which is the easier one. Now what you're going to do is you're going to focus on just one part, one half of the data. So we're going to focus on the lower half, which would be the numbers to the left of the median. So now since our line is right in between the 4 and the 5, we're going to try and find the median of this set of data. So then you can just use your fingers again, cross off the 4, cross off the 2. And since there's 2 3s here, I'm going to draw a line right here. So this would be my Q1 1, or my quartile 1, and my value would be 3. Now you're going to do it again for the upper half of your data. Now you're going to focus on those 4 numbers, and you cross off your largest and your smallest, and then our value would be between 6 and 8. So what number goes right in between 6 and 8? 7. So this would be Q3, quartile 3, which is 7. So right now we have our 5 important numbers, and they are called our 5-number summary. So I'm just going to put that off to the side, our 5-number summary. Our lower extreme, and I'm going to abbreviate because it is a lot of writing for this graph. So lower extreme is 2, upper extreme is 9, the median, or Q2, is 4.5. So median is 4.5. Q1 is 3. And Q3, our quartile 3, is 7. So those are our 1, 2, 3, 4, 5 important numbers to create our box plot. So now we're going to transfer this onto a number line. Okay, so you're going to draw a number line, and our data ranges from 2 to 9, so you could do from 1 to 10 if you want to, and break up the number line as best as possible, so as even as you can. Okay, all right, so there's my number line. And now when I transfer everything over, you can put a dot for each one. It makes it a little bit easier, but it's up to you. So I'm going to put a dot for each of these values. So a dot at 2, a dot at 9, a dot at 4.5. So 4.5 would fall between 4 and 5. A dot at 3, and a dot at 7. Okay, so these are the important parts of our box plot. So what you're going to do first is, since this is your median, you're going to draw a line. That's your median. I'm going to label it just with an M. And then this is my Q1. This is my Q3. And I'll put a line. And then that's my box. So I'm going to connect those lines to make my box. And then these are your extremes. So this is my lower extreme. This is my upper extreme right here. And then you just connect your box to your dots. Or your dots to your box. Okay, so there's my box plot. Now the whole point of doing this right here, I forgot to do it, but if you would have connected these, this is your box. And you connect your dots to your box like that. So we would make a huge big box plot on a fraction strip and transfer it onto a number line. That makes it a little bit easier to do. Now the other thing with a box plot is there are 4 different parts on a box plot. Yes, there's 5 important numbers, but there's 4 different sections on a box plot. So this section right here is 25% of our data. Even though it doesn't really look like much, it is 25% of our data. So from here to here is another 25. And from here to here, from the median to Q3 is another 25%. And then from Q3 to the upper extreme is another 25%. Because 25, 25, 25, 25, that equals 100%. That's all of your data. That's important. So if I asked you how much data is in this graph that is greater than or equal to 3. Greater than or equal to 3. So then you would go right here, 3, and everything bigger than 3. So that's 25 plus 25 plus 25. Well, that's 75% of the data is greater than or equal to 3. Even just looking up here, you have 1, 2, 3, 4, 5, 6, 7. You have 7 pieces of data that are greater than or equal to 3. Okay, now the last part is finding the IQR. So the IQR of this graph, it sounds harder than it is. So the IQR is the interquartile range. It's pretty much like the range of the box itself. So you're going to find the range of the two ends of the box. So you're going to take Q3 and subtract Q1 from it. So Q3, remember, was at 7. Q1 was at 3. And 7 minus 3 is 4. So our IQR is 4. The last thing that I wanted to talk to you guys about is the shapes of these box plots. These might be a little bit harder to tell the shapes, but one thing for sure is if you have, I'm going to draw one right here, just an example. So if my box plot looked like this, but my median was maybe right there. So my median is closer to the left-hand side of my, or it's closer to my Q1. So if the median is closer to Q1, that means all the data, or most of the data, is in this tiny little section. So most of your data is right here. So 50% is here, 50% is here, but it's spread out. It's skewed. So since 50% is on the left-hand side, then that means this would be skewed right. So if we do one that's the opposite way, and I'm going to draw my box, but now I'm going to have my median closer to the right-hand side. That's 50% of my data. And since most of the data is here, it is getting pulled to the left. So this would be a skewed left graph. All right, so that's one way to tell if it's skewed right or skewed left. You're going to have a question later on that asks you, is this graph uniform, symmetrical, skewed right, skewed left? And it's going to be one of these. I want to see if you were able to figure out if it's skewed right or skewed left. Make sure that you took really good notes because it should help you with your practice for today. All right, good luck, guys.